Hello everyone, welcome to ChemHive. Today we'll be talking on dimensional consistency. What is dimensional consistency? Simply means that each term in an equation must have the same net dimension and unit as the other terms to which it is added, subtracted, or equated to. What this simply means is that, for example, you have 6 meters plus 6 Newton. This is in length and this is in Newton, which is force. And this cannot be additive. When you have 6 meters plus 6 meters, this is additive because they both have the same net dimension and unit. So it's 12 meters. But if you have 6 meters plus 6 centimeters, they both are used to measure length, yes, but they are not having the same dimension. This is in meters and this is in centimeters. You have to either convert this one 2 meters so that it can easily add up, or you convert this one to centimeters so that it can easily add up. This is all what dimensional consistency is all about, making sure that the net dimension and unit of other terms to which it is added, subtracted, or equated to are the same. In this order, using the van der Waals equation, you can easily identify what should be the unit of A that can be divisible by V squared so that it can be additive to P, and what should be the unit of B so that it can be subtracted from V so that it can be dimensionally consistent. For example, if P has the unit of ATM and V has the unit of liters, what will be the unit of A and what will be the unit of B for this equation to be dimensionally consistent? We already know that the unit of P is ATM and V, A over V squared. You know that V are measured in liters, but this liter is having squared. So what will be the unit of A so that at the end of the day we arrive at ATM? We need to put ATM up here and liters squared so that this liter can cancel out and you are left with ATM, the same unit as P. So if P is having ATM, A should be having ATM liters squared. For B, which is in liters, what will be the unit of B so that it can easily subtract? B has to be in liters so that this can be dimensionally consistent. You can check it out and see. At the end of the day, we know that our A is ATM liters squared and B is in liters. I hope you understand what dimensional consistency is all about. We're going to solve more examples on dimensional consistency. So our first example is D is equal to 16.2 minus 16.2 exponent is about minus 0.021 t. We are asked to determine the unit of 16.2 and the unit of 0.021. 0.021. When we know that the unit for D, which is in nanometers, and T is measured in seconds. Find the unit for 16.2 and the unit for 0.021 so that this equation can be dimensionally consistent. At the end of the day, you put 16.2 into bracket 1 minus exponent minus 0.021. You can see that 16.2 should have nanometers. What of the exponent of it? Now this exponent, which is 0.021, has t attached to it, and the thing for us to do is to know the unit of 0.21. What should be the unit of 0.21? From the question already, we know that d, at the end of the day, when you simplify this equation, you're supposed to get nanometers as its unit. There's no second, but here it's having t. So we need to cancel out this t, which is expressed in seconds. What should we do to cancel out this t? We can say divide by seconds so that we can cancel out. So this means that we can write this as per second. 1 over s is per second. Therefore, 0.021 can be expressed with per second. So that this time which is expressed in seconds can cancel out. At the end of the day, when you simplify this equation, your d is supposed to be in nanometers, no seconds attached. So these are the units for each of this.